let's continue talking about some other things related to taking derivatives. First up is higher order derivatives. So this is like your second derivatives and third derivatives, and we've kind of mentioned this as a thing in class. Just so you understand the notation, we know that like f prime represents a derivative. So if I do f double prime, which also could be written as y double prime, that is, I don't want to use an equal sign here, that represents a second derivative. Okay. And that is kind of just like what it sounds. It's a derivative of a derivative. Now, we have a good contextual understanding of what a derivative is telling us, right? It's an instantaneous rate of change. What that second derivative is telling us, we're going to kind of talk about later on. But it's how fast is your rate of change changing, okay? If you are familiar with the concept of physics, think like acceleration, okay? That's what that second derivative is telling us. And then there's also situations where we can do higher derivatives even. We could do a third derivative. We could do f triple prime of x, which is the same thing as y triple prime, okay? By the way, sometimes, we write derivatives as like a dy over dx. You'll sometimes see this then as a second derivative as d squared y over dx squared. Okay, that's the same thing as a second derivative. And then same thing if it was a third derivative, there would be 3's there. After we get to the third derivative, and quite honestly, this doesn't happen very often, but if we want to take even higher derivatives than that, usually we scrap this whole prime notation and we use like just a regular number. So like I could do f6 of x, and that's talking about a sixth derivative. I think you'll also see this, usually you see it in this notation or this notation, but you may also see it written as y to the sixth. That gets a little fuzzy because it looks kind of like an exponent, right? But again, you don't run into these very often. Usually like the second derivatives are the important ones here. So if you notice in example 3, it gives us a function and it wants us to find f double prime of 2. There's no easy way to get there. I mean, it's not super hard to get there, but we have to start just by finding a first derivative. So I'm going to go first derivative, 5 times 3, so 15x squared, or x to the fourth, I mean, minus 24x squared plus 2x. And then the minus 5 falls away. To do a second derivative, I'm just going to repeat that process. Maybe pause the video and see if you can do the second derivative here. Okay, that's my second derivative. And then if I want the second derivative at 2, all I'm doing is plugging 2 into my function. So 60 times 2 cubed minus 48 times 2 plus 2. And let's see how my mental math is holding up here. This is 8, so 8 times 60 is 480 minus 96 plus 2. Okay, so that's 380, 384. So I believe this works out to be 386. And that would be my answer. And double check, I mean, if my math is wrong, somebody scream at me in the comments or something. But that's all there is to it with a second or third or fourth derivative. All you have to do is just keep repeating the derivative process. Okay, let's look at derivatives in a slightly different context. So in this next example, I have a table of values. I have two different functions here, f of x and g of x. And then I also have derivatives at f of x and g of x, but only of these selected values. So I don't have a whole equation to work with or anything. And we're just going to practice like this really gets at, do you understand your derivative rules and relationships? So k of x is f of x and g of x added together. So it wants me to find k prime of 4. Well, if this is addition in here, k prime of x is really just f prime of x plus g prime of x. Okay? And so if I want k prime of 4, that means I'm doing f prime of 4 plus g prime of 4. And I have actual numbers for those. So f prime of 4, I'm just reading. Here's f prime of 4, so that's negative 4/5, plus g prime of 4, so negative 1/3. Ew, fractions. Okay, that is going to be negative 12 over 15 multiplied by 3 there. And then this is going to be minus 5 over 15. So that gives me a negative 17 over 15. Okay, and that's it. That's your answer. Okay, so let's think about what this next one is going to entail. M of x is f of x over g of x. So if I'm trying to find m prime of x, this is a quotient. I'm going to need a quotient rule here, right? So I'm going to just write this out like this first. So with the quotient rule, I'm doing u prime v. So that's f prime times g of x minus v prime u. So that's g prime of x times f of x. And all of that is over g of x squared. Okay. Now, I want to plug zeros in. And just for the sake of space, here's what I'm going to do. I'm going to go through and make all my x's zeros. All of these are zeros now. 0, 0, 0, 0, 0. And actually now what I'm finding is m prime of 0. Okay, let's fill in all our numbers. So f prime of 0, 3 over 2. Again, this would be a good place for you to pause the video and see if you can fill in everything yourself. G of 0, now that's just the regular g of x function, so that's negative 2, minus g prime of 0, which is negative 1, and then f of 0, which is 1/2. And all of that is over g of 0, which was the negative 2, squared. So if this were a free response, I doubt this would be a free response, but if it were, you could leave your answer like that. You wouldn't have to simplify it. And actually, I usually advise that you don't, because if you try to simplify it and you mess something up, then you could lose points when this would have given you full credit. But because these are all just numbers, I am going to take the time to simplify here. So 3/2 times negative 2, my 2's cancel, but that negative sticks around, so I'm going to have a negative 3. And then here, negative 1 times 1/2 just makes me a negative 1/2, and I'm subtracting a negative 1/2, so this becomes a plus 1/2. And then on the bottom, negative 2 squared is positive 4. So, okay, I'm going to try to be proper about this here, because this really is negative 3 or negative 2.5 over 4. Let's make some non-ugly fractions though. So this is negative 6 over 3, or negative 6 over 2 plus 1 over 2, so that's negative 5 over 2 over 4. And then I can just combine my denominators, and this is really negative 5 over 8. Hey, last one. This looks like fun. Look at this z of x function. Okay, 3 times f of x plus g of x times f of x plus g of x over 2. And we're going to find z prime of 3. Okay, so I'm going to just start by putting in all the 3's here. So z prime of 3 is going to be, all right, let's think about this guy. This is 3 times the derivative of f at 3. So 3 times f prime of 3. This is product rule, okay? So this is going to like expand quite a bit here. I'm going to do, this is my u and this is my v. So I'm doing u prime v, so that's g prime of 3 times f of 3 plus v prime u, so f prime of 3 times g of 3. So all of this is the derivative of this piece right here. Okay, because I had to do product rule there. U prime v, v prime u. And then this guy, don't get fooled by this. This is not quotient rule because of that 2 on the bottom. We can really just treat that like a 1/2. And then g prime of that 3. I'm running out of space here. Okay, let's fill in a bunch of numbers. So we're going to say z prime 3 equals 3 times f prime of 3. So f prime of 3 is 0. That's nice. Plus g prime of 3 is -3. And I might do some parentheses here just so we can see what's being multiplied. F of 3 is -1. Plus f prime of 3 is 0. G of 3 is 2. And then plus 1/2 times g prime of 3, which was -3. Okay. This is gone. This is gone because those are multiplied by 0. So what I really have left here is a +3 and then minus a 3/2. And again, that's really 3 minus 1.5, so I would hope that you could look at that and say, okay, that's just going to be 1.5, or 3/2. We could think of this as 6/2, and then 6/2 minus 3/2 is 3/2. But that is your final answer for this guy. So we are just doing a lot of practicing with manipulating those power rules and product rules and quotient rules. You're going to get really, really good at these over time, but you just have to have some patience and be willing to practice. So that'll do it for this lesson. Go ahead and give the rest of your homework a try if you haven't yet, and we'll talk about this next time I see you.